Testing. Okay, so I guess it's an audio. Okay. Testing. Thank you. Okay, so the screen is up. And we have the Bedini SG here. Um, so here you have battery. That'd be your charging battery. This is your source battery. So your positive 12 would come out here. And your negative 12 is on this side, DC. And when this transistor is triggered and closed, 12 volts will go through the drive coil, the ground, and charge up in that bias. Plus on this side, up the top here is your plus 12 volts, and at the bottom is your minus 12 volts. So that's the biasing for this transistor, plus the minus, and that's the drive coil. Make sure this is recording. Yes, okay. So that's how the drive winding gets induced with forward charge. And that only happens when the trigger coil is fully saturated by the rotor magnet EMF, or the MF, micro uh, magnetic field coming off the rotor magnet. When it saturates this trigger coil, it will send a positive signal to the base, and the negative side will hit the emitter, triggering the transistor to close the gate right here. So there's no conductivity from here to here until the transistor closes the switch. And that happens when the rotor magnet falls over the trigger winding. And that would be this shot right here. Nope. Oh, okay. So you see the rotor magnet getting closer to the trigger winding. Once the rotor magnet falls over the drive coil, this is a point I need to make out here, that these two coils are wound in a bifilar around each other. Okay, so any field from a magnet that hits one coil will hit the other. So as soon as this magnet gets close enough to this coil, this is the drive coil. So the drive coil will saturate with magnetic field and distribute some of that magnetic field to the trigger winding. So the trigger winding then becomes triggered to be biased in this direction, meaning the positive north of the magnet on that rotor will be here, and the negative field of the magnet will be here. So the magnet and its magnetic field placing field on the trigger winding, they will place it with this polarity, so that plus 2 to 5 volts will go through here, hit the base with a positive signal, and the minus 2 to 5 volts, whatever the magnet on the rotor produces on the trigger winding, will go down this way to the emitter. Now the emitter acts like a diode, one-way gate. So this would be this side here would be blocking positive potential. So since this is negative potential here, it can flow. How do I put this? The positive potential is coming out through here, going that way, through the gate. And that's the direction of flow, from plus to minus. Again, your minus, the trigger winding is here. That part of the coil. This part of the coil is where the plus potential sits. And that's how this rotor magnet starts to impact the trigger winding and establish a bias with the transistor's base and emitter. Base receiving plus, emitter minus potential. And then the next stage, the magnet gets even closer to the trigger winding, and then the magnet passes fully over the trigger winding, and now there's enough current to activate that transistor for that duty cycle based on the amount of current that the rotor magnet induced onto this trigger winding. So now the trigger winding has fully triggered and closed the gate on the transistor. You could see that because the drive coil is now charging. And and it's charging from battery potential plus right here, source battery. It's charging through here because the switch closed. So that means you have plus up here on this coil and minus down here in the charge cycle. Okay. And then the charge cycle is over. This plus flips polarity and this minus flips polarity. That's the flyback. And that means that this becomes a minus up here and this becomes a plus down here. And because this diode is properly biased to feed into the plus side of the charge battery, the plus flyback will be biased properly through the diode to hit the plus terminal of the battery, course through the battery with flow to the minus side. So this coil basically here, the drive coil, releases its rebound energy back into the charging battery right here. That's your source. And that's how Bedini is capturing the flyback from the drive coil into the charging battery. During regular charging or forward charging of this drive coil, it will be getting a plus from here. So this will be the polarity put on the coil. And minus will be here once this switch closes and connects to the minus side of the battery, the source battery. That's your standard flow charge. And, this plus up top here doesn't reach down below here until the charge is removed. When the charge is removed, this plus potential shifts down here, and it's left in its wake a lesser potential minus. So now, this is your flyback polarity hitting this battery, because at this point, the gate is open. So there's no continuity from here to here. In other words, this plus potential cannot get over to this side when the switch is open. So it's forced to go through this battery to reach its minus potential on the other side of the battery. And that's how the flyback charges the charging battery during the off cycle of this transistor. That is, the simplest way to understand Bedini's method of capturing the flyback from the drive coil to the charging battery. You may be wondering what this diode here is doing. So when the rotor magnet is over the bifilar, inducing the coils, including the trigger coil, it establishes positive bias here on this side of the coil and negative down here. And the positive bias hits the base of the transistor. To be able to flow through here, it has to be positively biased through this gate to reach the negative of its same bias. And that's what triggers the transistor to close the gate here. So what is this diode doing? Okay. We know the biasing of the magnetic field on the trigger coil is like so, plus and minus. That means he doesn't want any positive potential to go this way to source negative. Which makes sense, because if positive potential did go this way, it would hit the negative of the same potential and cancel itself out, like putting a short over a coil. So what this diode is doing is preserving the flow that the rotor magnet created over the trigger winding. put it to flow in this direction. The flow it created is this flow. So it's counterclockwise. Any positive potential that can reach one side of the coil to the other will short itself out and not do anything. You'll lose that potential. So this diode blocks the potential from the rotor magnet from being canceled out over the line and creates a solid DC signal because it's AC without this rectification here. This whole part of the circuit would be AC analog current without this diode. So any analog signal or AC signal from a rotor magnet that hits the trigger winding will produce analog current with a pulse of, north-south pulse, which is analog AC. North-south from the rotor magnet. This diode is the clipping diode to clip the AC, make it DC. Blocking DC. Well, I guess, I don't know. Possibly. The actual flow is like the arrows say. And this is where your positive is. Going this way. So it would meet resistance at the resistors and tend to go this way instead. And that's how it becomes DC with the diode, low voltage diode, 4001. And and then there's your negative potential up here on the trigger winding. So positive signal would have no path to go. It gets blocked that way because of this gate. But it can go this way, back to the base. And the negative signal is curiously also on the base. The negative trigger winding signal is on the base with resistance. So you're able to use these resistors here to, they're variables, so you can lower the resistance and short out some of the magnetic field from the rotor magnet by lowering the resistance here. You can, delete some of that field, make your signal weaker. Or you can add resistance right here. And any positive potential that makes it across here will be less getting, back to negative because of the higher resistance you put here. So you limit the current like that. And when you lower the resistance here using the variable, I believe that's 100 ohm right there. You can mess around with that resistor value. But the potentiometer is variable. So and you're getting 100 ohms. What is that? 12 volts. Volts divided by resistance equals current. 12 divided by 100 is 0.12, so that's like 120 milliamps minimum. If you remove all the resistance on the trigger winding here down to 0, this 100 ohms will stay in effect and allow maximum of 120 milliamps. You can drop from there by increasing the resistance on your potentiometer. And you can go from 120 milliamps down to whatever, maybe 5 milliamps. So that makes a very weak sudden pulse on the drive coil, 5 milliamps. So I find to be more appealing as you use less power and you're trying to create the high voltage. And the faster you can open and close the gate here, the better. And the faster you open and close the gate, you can also limit the current going through the gate down to 5 milliamps or at a maximum of 120. So that would be, 5 milliamps going this way or 120 milliamps hitting the base. And that means, I think like 3 times more, the gate will release 3 times 120 milliamps. Something like that, maybe 350 milliamps. Like a multiple of 3 when it gets converted to, because you got to keep in mind the source is here, so you got a lot more amps to go from there. So all this has to do is close at its own value, and it's higher than whatever you put at the base, a couple times higher. So you might get like a couple hundred milliamps go through this drive coil when that closes. But you can get the same high voltage with the right tuning. You would use the least amount of amps to get the highest voltage. There's a tuning for that, but that equals whatever frequency that is. And that's how this trigger coil is, biasing through the diode in its circuit, sending plus through here, making sure it stays on this side. Create a solid DC pulse on the base here, 5 volts or whatever. Probably reaches a solid 5 volts after saturating. And yeah, that's what that diode does in a nutshell. So again, this is your trigger winding. This is your drive winding, the one that does the flyback generation and uses power to spin the wheel. So once it's charged, in this picture here, plus goes through the coil through here to negative. Yeah. Very interesting circuit. Very simple. You can expand on this concept in many ways by capturing the flyback once you understand how to do it like this. And so, you get plus and minus here from the drive battery during charge. That means that this is closed when that happens. And after it's done charging, this becomes a minus. It flips polarity, and that becomes a positive. And this is no longer closed. It's now open. So there's no continuity in the 2 points to the other side of the circuit. That leaves this drive charge battery in the path of this charge when the circuit is in that mode. Or, in other words, the transistor is off. And that's your high voltage flyback diode 1N4007. So again, it starts here, goes there, gets closer to the trigger winding, biases it in that direction, plus arrow pointing down, reaching to the minus of the same coil on the other side. That's the trigger coil. Then the magnet gets even closer to the trigger coil. And by that time, it passes by the trigger coil fully, initiating charge on the base of the transistor and the emitter with plus and minus charge on these 2 points to activate this transistor to close the gate. Basically, bring this arm down to this point, closing the loop in this part of the circuit, establishing flow of charge from the source battery to the drive coil. After that's done, the drive coil has been induced, and then the switch opens again because the magnet is passed and gone. And when the magnet's gone, there is no flow through here. There's no flow like this. It's like yeah. And meaning when there's no flow like that, that's because this magnet's not in the right spot. It has to be right about there. And then there's flow, of potential. It gets more flow as the magnet gets closer. And then there's full flow as the magnet passes the trigger winding, causing the gate to close, igniting this coil with battery power from the source battery for a brief moment. And then the gate opens again. And that plus charge from the source that was here becomes a minus charge. And this becomes a plus. The gate's open, so nothing can get through, but it can go this way over to minus. And that's what impacts the charge battery from the flyback. Keeps the charge battery charging. All right, I'll cut it there. Hope that made some sense. And I'll re-edit this later. Put some audio. Over and out.